2016? 16 BC Calculus FRQs 3 and 4. As always, read the full question. That seems to be the key to doing these. So, first one, you got your standard graph. And the first thing you have to do is say, okay, this is F, and G is the integral of F dx. So basically we're looking at the derivative graph. We could almost say this is F prime, and they're going to ask questions about F, but that would just get very confusing, so I'm not going to do that. So does G have a relative max min, whatever, at x equals 10? I'm going immediately with neither because I've been doing these problems recently. And I'm going to say the slope, because I am looking at the derivative of G, is negative before and after x equals 10. Now I have an answer key elsewhere. I wrote that the graph of f does not change from positive to negative or negative to positive, so this is pretty much just as good. Does the graph have a point of inflection at x equals 4? And the answer is yes. So let's see if I can write in y. B POI at x equals 4. Yes. Slope, the slope of the derivative, so this is 4, changes from positive to negative. A lot of people get hung up because they say, well, you can't take a derivative at that point. That's got nothing to do with it. What's going on before and after is what has everything to do with it. So don't get hung up on that one. Let's see, and I'm making a bit of a mosh of this, but that's okay. C, find the absolute min, absolute max, -4 to 12. And this one requires a fair amount of work, and I will shortcut it. But here's what people had problems with. I'm looking for where it breaks and then the endpoints. Alright, so we start at 2, don't forget that. We want G of -4, G of -2, G of 6, and G of 12, and that's the integral from 2 to -4 of f of x. I really should call it f of t. dt. Not showing the work. We're going left. So we're above. So this is negative and this is positive. If you add those up, you will get -4. G of -2 is again from 2 to -2, f of t dt. It's just what we did before, except we don't add in the little piece on the bottom, we just subtract the top pieces. Get -8. I'm going to underline that for later. This is from 2 to 6, f of t dt. Now we're heading to the right, so this is all positive, and that's it. There's no negative. So that, if you do the math, 1/2 base times height is 8. And then from 2 to 12, f of t dt equals -4, because everything that comes later is negative below the x-axis. So this is your absolute min, and I would write this out again. I'm just a little stretch on space, and 8 is your absolute max, and write out what I just said. Find where the derivative goes from positive to negative or negative to positive. Check your endpoints in those points. Here it is. Therefore, that's your justification. Negative 8 is your absolute min. 8 is your absolute max. A lot of people try and write a book to explain it. All you got to do is say what I just said. Where to go from min to max, and I checked my endpoints. Here's what I got. Find all intervals which g of x is less than or equal to 0. I swear the College Board keeps messing with me. The difference between parentheses and brackets here. Not going to worry about it too much. We start at 2 and we go left, and it will be negative because we're going left, it's above the graph, and then this will be a positive chunk, but this chunk only cancels with that, so it's going to be negative all the way back to negative 4. So we're looking at, according to them this time, negative 4 all the way to 2, because once we get to 2, this is 0, this is positive, that cancels out, so that's all going to be positive between here and here. But then starting here, it'll be negative from 10 to 12. And again, they're going with brackets. I really wish I could get a lockdown on that. I'm hoping to be a grader sooner rather than later and say, yes, you can definitely go with brackets or parentheses, or no, they really want. I find it very annoying. So that problem's a 15-minute problem. It's closer to 10. If it takes you 15, it takes you 15, no big deal. This one I was very surprised. It took me some time. So they give me a differential equation. I look at it and say there's x's and y's in there, so I'm probably going to see Euler's method. I can't separate the variables, so they won't do that. Maybe there's some implicit differentiation. We'll see what happens. So that's the y dx. They want d squared dy dx. So d squared y over dx squared is 2x times dx over dx, which is 1, minus 1/2 times 1 times dy dx, which is 2x minus 1/2 x squared minus y over 2. I actually ran that out. I wouldn't bother, just likely to make a mistake. I didn't, but you never know. Let y equal x particular solution, negative 2, 8. Does graph have a relative max min at that point? Well, first things first, let's see if the derivative equals 0. So we get negative 2 squared is 4, minus 8 over 2, which is 0. So check, we have to find out what's going on. Now, if you've been doing this for a while, you probably say, well, let me go look at the graph, or let me integrate that and figure out. If we've got a differential equation, we can't go that direction back to the integral. We are stuck with going with either dy dx, which we just did, or the second derivative. So in this case, the second derivative is negative 4 minus 1/2, 4 minus 4. Very slippery here to make sure I get it right. So second derivative is negative, meaning it's concave down. Since it's concave down and dy dx equals 0, negative 2 comma 8 is a relative max. And a lot of people are, oh, well, how do I justify it? I just did. You don't have to do anything more than that. All right, this one takes some time. You look at this and realize it's going to be 0 over 0 when you plug in negative 1 for x and 2 for y. So here's how they wrote it up. Limit as x approaches 1 of g of negative 1 minus 2 is g of negative 1 is 2, so 2 minus 2 is 0. Limit as x approaches negative 1 of 3 times x plus 1 squared equals 0. You can write out the math if you want. So L'Hopital, we go again. We get limit as x approaches negative 1 of g prime of x at x equals negative 1, which is g prime of x is dy dx. When x equals -1, y equals 2. We plug it into the derivative and we get 2 squared 4 minus, try again, -1 squared 1 minus 2 over 2 is 0. And then derivative of that one, x approaches -1 is 6x plus 1, x equals -1, also 0. L'Hopital again. And I am going to run out of space, so I'll bring it down here. You get second derivative of x, limit as x approaches -1, which is the second derivative, so you plug in x equals -1 and 2, and you will get -2. And then the bottom, limit as x approaches -1, you take the derivative, you just get 6. So final answer is -2 over 6, -1/3. And yeah, that's a lot. I mean, that's a real lot. I can't imagine seeing that in our near future, but be prepared. I mean, that's tricky stuff. And finally, last but not least, little D, Euler's method, right? Delta x dy dx delta y. I actually usually put an xy out there, but I've run out of space. Well, I can't have that, so let's fix that. So part D, x comma y, delta x dy dx dy x comma y. Now they say start at 0, 2, go up to 1 by 0.5, so it's going to be 0.5, 1, and I don't know what. This is going to be 0.5 and 0.5. This is going to be 0.5 and 1, and I don't know what. Dy dx, plug it into the original, plug in 0, 2. That's a 2 if you can believe it. And you should get -1. Multiply, get -0.5. 2 minus 0.5 is 1.5. So this is 1.5. Apologize for the messiness. Dy dx, crank it out, you'll get -1/2. Multiply, you get -1/4, or -0.25, so you get 1.25, 1.25, and that's what you get, 1, 1.25. Handwriting's a mess, ran out of space. Like I said, the second one, that's a full 15 minutes. I'm pretty good at this, and even I was like, wow, that would take a lot of time. So good luck.